welcome back to the last video segment on spatial query language. We have had a long journey. We started with the notion of queries, query languages. We walked through the old SQL. We also discussed why it was so inconvenient to model spatial data and queries in old SQL. Then we got into the OGIS with SQL3, which allows us to at least specify simple spatial queries, and we saw even spatial joins and so on. And now we are going to wrap up this journey by telling, by at least summarizing things and telling you that there is more. So if these things work out, for your goals and you want to learn more, there are more things you can explore. Okay. So at the end of this video segment, we are going to know a little bit about the trends in spatial query languages, and also know a little bit more about SQL3, the mechanism using which these query libraries are added. Okay. So the key thing is to know about SQL3 is the following. It has provided a mechanism to add user-defined data types, and once you have that mechanism, many different libraries can be added to SQL3, and each library can have a new set of data types and operations. So what you saw in OGIS is just one example, but there are many other such libraries which are being added. Okay. So for example, you may have spherical data types that are added. People have added other things like XML and so on as well in SQL. But within geographic data sets, they are looking at raster, graphs, and so on. Okay. So, so whichever libraries get popular, then those get adopted by many vendors. Okay. And in addition, if you don't find the libraries that you are looking for, you can go add your own library. And some of that is happening today, particularly for GPS tracks. So, using OGIS, you can't model the time part of GPS track very well, and a lot of people now are generating GPS track data, so they are adding their own libraries. Okay. So we are not going to actually get into a lot of detail of this mechanism called create type, but let me just give you a glimpse how these things are added, so that you might at least look at other libraries or add your own. Okay. So create type, the syntax looks very similar to create table. It's part of data definition language. So in this case, we are creating a new type and the name is point. Okay. And inside this type, we can list its attributes and methods. So for example, in point, we wanted two different numbers, right? X coordinate, Y coordinate in a planar system. In spherical system, you may have latitude, longitude, altitude, and so on. You can also add methods. So here you are showing a member function. The name is distance, where there are two arguments. One is specified here, which is another point, and you may want to wonder where is the first argument. And if you came from Java, Python, object-oriented world, you realize that the first argument is the point itself on which this method will be called. Okay. And then we can have also other ideas where interface and implementation is separated. So here I am not showing you implementation. For this function, only thing I showed you is interface. And finally, it has a few other details which are SQL specific. You may not see them in other languages. And it basically puts some restriction on what kinds of things can be done further with this object. Can you define subtypes? Can you use it to instantiate objects, and so on? Okay. So, but using this facility, you can actually define many libraries, and there are many which are coming along. So with this, let's go and try to summarize our discussion. We started with our first query talking about queries and query languages. So queries at a high level are simply questions that can be posed. Okay. And query languages provide you a declarative language to pose this question, where you don't have to say how to answer it. You simply say, this is the subset of data I want. Okay. SQL is its declarative language, and starting in mid-80s, it has become very popular, and this is sort of the language almost all databases speak today. In many cases, you may see a graphical user interface in front, and it may allow you to do point and click, such as in a geographic information system. But then those interfaces generate SQL to a backend database and on your behalf. Okay. Standard SQL used to have very simple data type like numbers, currency, and so on. And those were not really sufficient for spatial queries. It used to be very tedious to write spatial queries back in 80s. So through 90s, a lot of discussion happened. The vendors and the user communities came together, and they added user-defined data types, which allowed us to add spatial data types. And one popular library of spatial data types is OGIS, and particularly the simple feature types within OGIS, which is widely implemented, and it's worth knowing. Okay. But that's not the end of the world. As we just mentioned, there are other libraries because create type statement allows you to add more. And the vendors have brought out new libraries, and even more are being added today with newer types of geographic data such as GPS track. So as you develop more interest in this topic, you can go learn about those libraries. And finally, here are some more references. If you wanted to see a little more detail of the basic material, you can look at chapter 3 of this book on spatial databases. And if you want to see the syntax in a public domain library such as Postgres, you might see this encyclopedia article. If you are looking at or this encyclopedia article on PostGIS. And finally, some vendor specific syntax is given in an Oracle spatial article inside Encyclopedia of GIS. So I hope you will enjoy this journey and you will try the basics and go beyond and try some more details of this topic. So with this, we'll wrap up the discussion of spatial query languages, and hopefully we'll see you in another module on spatial data mining or location-based services and so on pretty soon. Thank you.